Hi, I'm Tommy. Welcome to this third video in my Finite State Machine in Unity tutorial series here on Table Flip Games. In the first two videos, I set about building the example I'd shown in the first original video, where I have a character that moves around an environment using a finite state machine with three specific states. I then started by creating a really simple abstract class that I would use for each state within the machine, followed by a more concrete example where we had an idle state that does, well, at present it does nothing, really. And one of the reasons it doesn't do anything is that there isn't a state machine that's actually executing it. So let's start building the state machine in this video and have it run the idle state by default, and we can kick things off from there. But what I need to do in order to start is I actually need to have a really simple class for my non-player character that's actually going to manage, model, and then also execute the finite state machine. I have my NPC here. I already have a navmesh agent attached to it, and a navmesh agent is what we actually use for a navigation mesh, and I'll come back to that in a later video once we start adding in the patrol behaviors. But that's how it's going to be able to move around this space, as we actually have a navmesh built into that scene, as you can see here. Also, on that note, if you are looking at that thinking, well, I actually don't know how to use navigation meshes yet, be sure to go and check out my separate nav mesh in Unity tutorial series that I also have here on the Table Flip Games channel. Whoops. How did that get there? Wait. Trying to maintain my cool here as I'm trying to explain something to you, and Unity's blowing up. Alright, so what we'll do is let's go into my code. And I've already got an NPC folder. Let's just go back into where we were. You might remember this from the last video. I've already got this NPC patrol point. Now we'll come back to this. This is actually based on code that I wrote already in the navmesh tutorial series. I'm going to come back and explain this later on. So for the now, you can just go away. But I want to add a new class. And I'm just going to call it NPC. Yeah, we'll just call it NPC. I was just trying to think of something else, but nah, that'll do. And there we go. So I'm going to make this a public class. It's also going to inherit from mono behavior. That way I get my awake method, and I'm going to have my update. We'll have start rather, actually, and then we'll also have update. Now I'm getting an error here. That's because we haven't set the using for the Unity engine, but that's that fixed. One of the things I want to do is I'm going to be able to store two variables that I need as part of the execution of not only the agent but also the finite state machine itself. I want to maintain a reference to the finite state machine, but I also want to maintain a reference to the navmesh agent that's attached to this character. So one of the things I want to do is I'm going to actually embed a rule that says whenever I create an instance of this, there has to be a navmesh agent and a finite state machine attached to the same game object, and if there isn't, it will also add them as components. So we're going to use the require component tag up here, and I'm going to start off with type of, and then navmesh agent. And that's all I'm going to do for now. And make sure I'm using the Unity engine.ai to get access to the navmesh agent. And on awake, actually what I'm going to do is I'm going to create a separate navmesh agent variable. Call it navmesh agent. And I'm going to say on awake, navmesh agent equals this dot get component navmesh agent. Now, I don't actually need to do this dot here. If you want, you could just call get component. But for me, it's actually the faster way for me to cause the autocorrect to kick in. And also, I just like being able to see the this dot. It's just the way that my brain works. I like to be able to see that that's how that's going to behave. So that's already going to work out fine as is. If I quickly build it and we get that moving. That build has succeeded. So if I quickly go back in, I'm going to go into my NPC and I'm going to add this new component to it, which is NPC. And I'm going to move it up. Yep, I'm going to break a prefab. It doesn't matter because I already broke the prefab anyway. I've just been storing everything as prefabs to make it easier for me to come back to this example. But there we go. We have an NPC script. And that's really about it at the moment. What are you complaining about? Never mind. That's just Unity breaking on me. So with that done, the next thing I want to do is actually build the finite state machine itself. So let's go back into Visual Studio and close that states folder. And we've already got the abstract FSM state, but in the FSM folder, I'm going to create a new class that is called Finite State Machine. Voila. And yeah, we'll also make this public class, and it's also inheriting from mono behavior. I'll make sure I put the using Unity engine at the top, so that stops complaining. All right. Now, what I want to do is I want to maintain a reference to a current state that we're executing as part of the state machine. And that's the state that we're going to, when the on every frame of tick within the Unity engine, we're then going to call that state here. So let's start. I'm actually going to start by creating a variable of type abstract FSM state, and I'm going to call it current state. And I'm also going to, just for the sake of this example now, we might change this later on down the line, I'm going to create another one, which is starting state. And I made that serialized field because I want to expose that in the editor, because I'm actually going to drag and drop in one of the scriptable objects that we're creating in there as the starting state for this character. So let's go into the awake method, get things up and running. And we're going to start with current state is null, just because I just really want to check that. I just feel like that's a really nice thing to do. And I think that's it for this point. And then what I want to do is I want to wait till we get into the start method. And on start, what I want to say is if starting state does not equal null, I want to enter a state, which is the starting state. That means I'm going to have to write a new method for that. And I'm going to create a little region, which is called state management. And that allows me to just kind of block that code out in that particular corner. And so this is a public method, and it's going to be enter state, public void enter state. And right now I'm getting it to pass in a particular instance of FSM state. Now I might not keep this. One of the things that I've actually done before is I actually use an enum that represents each state that I have that I can use in my state machine, and then it auto generates one of them. But this is actually another way to go about it, so I think, yeah, we'll stick with this for now. And we're going to pass in, I'm going to call the parameter coming in, it's of type abstract FSM state, and we're calling next state. And what we'll say is if, well, we've already got the this if null does not equal null check here, but actually I'm just going to do it again because I might call this method from somewhere else down the line, and it would be nice to make sure that it's always correct. If next state does not, actually, you know what, I'm just going to say if it is null, and then if it is null, just bomb out of this method. Otherwise, current state equals next state, and we're then going to ask current state to enter state. Now you might remember back in abstract FSM state, we already have this enter state, which sets its execution mode to be active, but also in the idle state, I overrode that method so that it would then say it's entering the idle state there. So we should actually be able to see this when the finite state machine begins to operate. Okay, smashing. Also, we'll get to this, but one of the things I'm actually going to add in soon is another instance of abstract FSM state, which is the previous state, and that's going to be really useful when it's transitioning from one state into another, because we might want to know what the last state was, just in case we want to snap back to it in the event of an error or something like that. And then I'm going to quickly implement the update method. for finite state machine, and what that's going to say is if the current state does not equal null, then yeah, let's just update the current state. I think that's about everything I want in this at the moment. And then the only other thing I'm going to do is I'm going to go back in here and I'm going to make a reference to the finite state machine variable here in the NPC. And I'm going to also add it as another prereq of my NPC. That way I've always got an instance of these two things attached. And finite state machine dot equals this dot get component navmesh agent. Oh, whoops, navmesh agent, sorry. Coffee's not quite kicked in. There we go, finite state machine, smash 'em. And this will actually get fleshed out a lot more as we go on down the line. What have I missed? I've missed a bracket up there. There we go, that'll be fixed now. Compile it. Now the thing is, at present, with this current setup, it doesn't automatically add the finite state machine to this NPC because that script was already attached. However, if I was to actually just quickly remove that and then re-add it, you'll see it also adds a finite state machine to the same, yeah, break that prefab, it's fine, don't worry about it. It actually adds the finite state machine component to this game object, which is quite nice. So now I have my navmesh agent and my finite state machine attached here. I'm going to quickly save that. And I need to add a starting state. And I'm going to just drag and drop this existing idle state that I already made. And now it actually has a starting state to run from. Let's quickly run it. And there we go. Fantastic. So you can see it entered the idle state, and then on every frame, because this is every one, I've actually collapsed this because I like to collapse my console. If I uncollapse it, you can see every frame of the game, it is updating the idle state. So now we actually have a finite state machine that is maintaining an idle behavior. It's not doing anything right now, and it hasn't got a reason to change its mind about what it's doing, but this is a starting point for us to actually build from. So what I can do in the next video is, now that I've got this finite state machine and all it's doing is sitting idle, I've got all these trappings in place for me to expand the example, and I'm going to try and add in the patrol state next, where the character actually starts moving around the space and visits specific points in the world. And like I said already, this is going to be based on some existing examples I've done over in my navmesh tutorials, which you can also find on the channel, but the important thing is we're going to have the state machine oscillate between two states. We're going to have it on a movement state where it moves to particular points in the world, but I'm also going to expand the idle state to allow for it to only stay idle for a short period of time, and then I can actually transition to another state that I want it to move into. But anyway, for now, thanks for watching part 3 of this Finite State Machine tutorial here on Table Flip Games. Don't forget to like and subscribe for more of these videos, and join our Patreon for access to all of our source materials. See you later.